All right, well, we should be live here. Muvafik, thanks for joining me today. Welcome everyone who's here in the chat. We're glad to have you back for another episode of TBS. This is a particularly exciting episode because we're going through our API standards document and then also some of its implementation across our stacks. And I think this is something that's really applicable to the wider Kubernetes community. And Muvafik's on today because he actually wrote our document, which we'll get into in a little bit. And so he's going to kind of walk us through it, and we'll do a bit of an interview style here. So maybe it'll be a little more interesting than the usual just hearing me ramble on. But anyway, thanks for joining, Muvafik. Do you want to give kind of like a brief introduction of what you do with Crossplane and Upbound?
Yeah, sure. Thanks for having me. So I joined about like 6 months ago or something. And since I joined, pretty much I've been developing controllers, especially in the part where we talk with the cloud APIs. And so far I like it pretty much, our team especially is like completely distributed, like we all work remotely. And I'm happy that we do have a culture of remote working and async communication. So happy to be here.
Yeah, for sure. No, I totally agree with that as well. Like for instance, Muvafik is in Turkey right now. I'm in St. Louis, Missouri. The company's headquartered in Seattle. So we're definitely all over the place. So it's a really cool opportunity. And I think it's like an interesting experiment that a lot of companies are going through right now. Or maybe it's not even an experiment now. It's kind of proven that working remotely and distributed gives you access to more talent. And I particularly like it as an employee because I meet people like you, which is super awesome because like we probably never would have crossed paths if there weren't remote friendly companies like Upbound. So it's been super cool. And then it also, I think, caters well for us just being involved with the general Crossplane community because obviously open source projects are distributed all over the world. So kind of having the core team fashioned in that same manner, I think is really valuable. So yeah, like I said, we're going to talk about our API standards doc today and then some of the implementation. I'm going to go ahead and look at the comments here and see if we have any people. So Marcus, who is probably our most loyal listener, is in the comments with us here. So good to see you, Marcus. It looks like we have a couple other people on here right now. So if you're here, feel free to comment. Jared, he's on here as well. Jared's one of the founders of Crossplane, and we're glad to have him here. And so, yeah, just along the show, Muvafik and I will both be checking back in the comments to kind of see what's going on and if people have questions or thoughts. So please feel free to introduce yourself, and we'll definitely give you a shout out. So let me go ahead and share my screen here so we can take a look at the doc and some other stuff we're going to talk about. So let's see, Muvafik, can you see my screen okay?
Yeah.
Awesome. So this is the document that Muvafik wrote up for us. And before we get to that, I wanted to ask you a little bit about how we kind of go about designing these documents. So obviously you'll see that we have this design directory in Crossplane, and it's full of quite a bit of stuff here. And some of them are labeled one pager, some of them labeled design doc. And we have an outline of that here, but just kind of to like humanize it a little bit. Would you mind talking a little bit about just kind of what the purpose of one pagers are, what the purpose of design documents are, and how we go about writing them?
Yeah, sure. Well, this is actually like specifically one of the things that I like most at Upbound. Like before we go ahead and implement something, we usually come up with an issue, and then like if it's a little bit bigger than that, we start to write, one pager that explains, the terminology background, like why we need it, and like a proposal around how to solve it. And like this gives everyone to comment on the document and like, weigh in like from different perspectives. And also, it's open completely. So sometimes community members come in and, tell their opinions. And about the leveling, so like usually we start with issue, then move to one pager, and if it's like really big, we write a design doc. But I guess like lately, like the line between design doc and one pager has come to be a little bit blurry. Like we usually go with the one pager in general. But yeah, like it's really a good way. Like sometimes it's a bit hard, you know, because you're not implementing, you're just, you know, writing a document. But like later on, you see that everything you did is documented well enough, and like, you know, people can come in and see like how it's actually designed instead of having to go through the code and like, you know, trying to track the flow of the, you know, execution.
Yeah, no, I definitely agree with all the things you expressed there. There's a couple things that really stick out to me in addition to that. So one that I wanted to look at here is something I worked on, and just to point out, this is just a good example, and there's a couple of other ones like this as well. You'll see that this has 96 comments on it, so you'll frequently see a lot of comments on design docs because it is a longer review process. This design doc in particular was for consuming on-prem Kubernetes clusters and that sort of thing, and scheduling applications to them. And you'll see that there's kind of like a variety of viewers and reviewers. So we have people who are kind of more high level, more technical, and then just community members across the board all weighing in. And a design doc is a super great way to do that because it's, you know, laying out what we're going to do before we do it. So, you know, a lot of open source projects will say, you know, we develop everything in the open, but you're not really practicing that if you just open the PR with all the code changes, and it's really hard for people to follow. And before that PR was open, they didn't really have a say on it. So I really believe that design docs and talking about things before you implement them is certainly a core thing that is necessary in any open source project. So I totally agree with that. And one thing we'll see here when looking at your design doc, for instance, is, if we can get this to load here, the at the top of all of these, let's see, here we go. We'll have this stanza that says the owner and reviewers. And I think that's a really good responsibility model. So for instance, I believe I recently did an update to this document, but having you as the owner kind of gave like a clear kind of assignee for reviewing what was in this document. So you're saying by putting your name on this that, you know, when this document is updated and that sort of thing, that I'm going to be responsible for making sure it's accurate. I'm going to be responsible for if changes happen that don't go through a design process, that they're reflected here so that these documents stay up to date. So yeah, I love that aspect of it. So thanks for running down that with me. I also want to take a second. It looks like we have another friend in the chat. I apologize if I pronounce your name wrong, but it looks like Amit from India. Thanks for commenting and letting us know you're here. I'm really excited to have you on. This is your first binding status episode. Feel free to check out our repo or any of our old recordings, and also join us in Slack. All right. So the core of today's episode is this managed resource API design patterns, which is essentially, if we're boiling it down to kind of like a one-sentence summary, is how we translate cloud provider APIs to CRD schemas. That's essentially everything we're doing here. So in Crossplane, you're probably familiar with, we have different stacks. So we have core Crossplane running, and then stacks represent different providers. So essentially, if you are using GCP and AWS, you just plug in those stacks into your core Crossplane, and then you're able to consume managed services from there. So each of these different cloud providers have SDKs and APIs. And so for instance, Google Cloud Go is one we use for our stack GCP. And what you'll essentially see here is just all the different managed services they provide and ways to interact with their API via code. So when you look into things, you'll often see different structs inside of here that have clients for interacting, as well as maybe objects that you send. And we have to translate those to kind of like the open API v3 schema for CRDs. And we want to be consistent across the board with how we do that. So I was just showing the GCP API, but the AWS API can look quite different. And then when you get to smaller, more focused cloud providers, it can expand even more. There can be some intricacies to how each SDK works. So designing a spec that is kind of encompassing of all APIs, while also being specific about when someone's implementing a new one, that they know exactly how to approach every situation, is really important for us. So we're going to walk through how we do that today and show some examples from a couple of different APIs. To get us started, I think it's always important to look at the terminology, and you've put a great section here defining. So just briefly, the two main things that we're focusing on here would be the external resource, which is when we talk about, let's say a Cloud SQL instance running on GCP. So that's something outside of Crossplane, outside of where Crossplane is running. And then the managed resource is the representation of that external resource in Crossplane. So we have a CRD for the external resource, and you create an instance of that to represent it. And that's what Crossplane basically uses to store the information about what you desire that external resource to be. And then within that external resource, you have the spec and status. So the spec is what you desire for the resource to look like, and the status is basically what it actually looks like. And we'll get more in depth into that as we go through here. And Movafic has a lot of insight as to how those two things differ and how we decide what goes where. So kind of the first thing I wanted to ask you about Movafic was, why did you think it was necessary to put this into a doc? This kind of came about after a lot of stacks and had already been implemented in Crossplane. So we had some existing patterns, but it differed between different cloud providers and that sort of thing. So what was kind of your thought process for wanting to add this? And were you running into any pain points that kind of made you think we really need to have a document that explicitly says how we're going to handle this?
Yeah, definitely. I mean, so like after I joined, when I ramped up, like almost every controller, like managed resource controller, looked a little bit different. We are, reflecting the PVC PV model of Kubernetes. So here, like PV corresponds to managed resource, like which is where you talk with the cloud API, and like they all have, crazy structures and stuff. So every controller looked different, and so actually a little bit history here. Before I joined, we had a claim reconciler, which is what works between claim and the volume, let's say, like managed resource. It was a generic one, and like our team lead Nick, his brilliant design it was just like we were using same reconciler everywhere. And like we started talking with doing the same thing for managed resource, as a first step for consistency, as like our controllers should look at least similar, so that we can just improve them all at once, or like newcomers can just learn one thing and like apply it to others. So, and like he started the architecture, and like I took over from there. And then after this is done, when you make something generic enough, or like automate something, you're striped away from those mundane tasks, but you actually have new problems, like you have more high level questions to ask. For example, okay, like we have the controller logic in a generic way, but like now let's get to other problems with like for example, how to name the resource. We like users say, hey, I want a cloud SQL, or like I want a database actually with a claim. So how do we name them? Or other decisions, such as what do we do if the resource is already existing? Or what does spec look like? In general, in Kubernetes, spec is like your desired state, and status is your observed state. So it should look like this in our case as well, because like we are extending Kubernetes. So but also we are translating the cloud API. So like it has to be like users should be able to use Crossplane and like not need to go to AWS console or like, GCP console and stuff. So like there are a few like, there were many like pain points that like during like, implementing something, and like as step by step, like first starting with claim reconciler and then managed reconciler. And then we got to, a point where we want to make, some decisions and like apply them across the board.
Definitely. Yeah, I think one thing you touched on there was the ability to implement these shared reconcilers, which I am not pulling up right now because we're going to get to them later. But they're one of the most valuable core pieces of Crossplane, I think. And so I'm excited to talk about kind of how those are used with these conventions. So kind of to get started off here, there's kind of a core principle that I think permeates all of our different managed resources, and that's this idea of wanting to be high fidelity. And it's talked about in this document here a few times. You'll see the term high fidelity. Before we get into naming or anything like that, would you just kind of give us like a definition of what high fidelity means in this context?
Yeah, sure. So basically, high fidelity is being for a resource to be to have high fidelity, it has to represent like everything cloud provider exposes. So basically, if you're using Crossplane, you shouldn't, say, hey, Crossplane is not supporting this yet. So like it's just one field, but there isn't any support. So this is a basic idea, but like there is this, we're extending Kubernetes on one side, and on the other side, there's a cloud APIs, which are like, totally different. So basically, high fidelity is not, let's say, like easier said than done, basically, because like you have to come into a place where you still follow Kubernetes patterns, like not leak some points during your design, but also you have to expose everything that cloud APIs exposes. So basically, high fidelity is one stakeholder, a big one, as big as I would say Kubernetes patterns, and like we're trying to bring them together in a consumable way.
Definitely. Yeah, I think something really important that you said there is that we want to reflect everything that's possible in the cloud provider in Crossplane. So there shouldn't be anything you can do in the console or via the API or anything like that you can't also do through Crossplane. Another important distinction that we make with high fidelity is that we don't kind of have side effect resources, right? So a lot of times in a cloud provider, if you are creating the more managed the service becomes, essentially, when you're creating it, there's a lot more like side effect creation, right? And if those side effect resources are not tightly coupled to the original resource that you're provisioning, then we want those to be managed via separate resources, right? We want to represent them the same way the cloud provider does. So if we have something, that includes, for instance, right now we're working on GKE on Google Cloud. There's node pools that are associated with a GKE cluster. Well, what we want to do is, in the GCP API, you can look at that and there is a way to interact directly with the node pool. So that's a separate object that's presented to you. So in Crossplane, we want to be able to do that same thing, right? We don't want to just say, create a GKE cluster and, behind the scenes, we'll provision your node pool and it will auto scale and that sort of thing. We want to empower you to be able to do that, but we also want you to be able to configure it as detailed as possible, right? We're trying to have the full configuration that's possible on all the different cloud providers. So that's something I think it's good to keep in mind when reading through this.
Yeah, exactly. So like
ahead.
specifically for your example, so when you try to do the high fidelity, but also follow the Kubernetes pattern in the GKE, you are actually able to define your node pools in the GK API.
Mm-hmm.
So, but like since they are imperative APIs, like RESTful APIs, like there would be any problem. But in our case, since we're continuously reconciling, we're not able to put one node pool resource and like also represent it under the GK resource. So basically, like we're going like in this document, I think there's like specific examples for this, but like these are like, problems that we, run into in general.
Yeah, definitely. And that's really tough when resources are, side effect provision on the cloud provider, but also provisioned individually, because we don't want, those separate objects existing, because you'll have duplication or you'll be missing something. And so you won't clean up everything or something like that. So you mentioned earlier naming conventions. So like that seems like the simplest part of creating external resources. Just, choose a name. It's not really that important. You might identify it with tags or something separate than that. But when you're reflecting names in a separate system from the external provider, and you're also doing it on multiple providers, that becomes a little bit more of a difficult situation. And some cloud provider APIs, have in the call to create the resource where you specify the name. Others kind of just say, we'll create the resource and then tell you what the name is. And if you're using a console or something like that, that's not really, a big problem, right? Because you just create it and you immediately see the name. But if you're declaratively specifying things, it's inherently not declarative if you only get the name after the resource is created and you don't really have a say in how it's made. So I know leading up to this show, we talked a little bit about like a VPC on AWS. You create that and it kind of creates a VPC unique identifier, and then just kind of tells you what that is. But then something like an EKS cluster on AWS, you can say, my cool EKS cluster, and that's what the name of the resource will be. And when you make API calls to AWS, you can refer to it in that way. So when we have these two different kinds of either declarative or non-declarative naming, how do we handle that in Crossplane? I believe you actually developed this strategy for us, which has served really well so far. And there's some kind of speculation about that it may pay off in terms of importing resources as well in the future. But will you talk a little bit how we handle those external names in Crossplane?
Yeah, sure. So I mean, the starting point, like for designing this mechanisms, are like the users, like our users, interact with the Kubernetes API. So what they see is like, claims and like managed resources. And these resources, they also have like name and namespaces and like, logical groupings via namespace and stuff. But like this actually doesn't reflect the cloud APIs. For example, you can't really have your namespace in AWS to, logically group some resources or like, any like some random cloud provider. So the starting point is that we want to be able to, reflect the resources in the cloud provider as close as, how we represent them in our cluster. So what we do is basically, let's say we start with, the resources that you can actually name them. So what a usually user does is like, you create a resource class and then you create a claim. And then our controllers start and create a managed resource for you. So there's one naming decision there. Like, what do you name your managed resource? Is it like same name with claim, or like, basically what, or is it like UID and stuff? And also managed resources are cluster scope, so they don't have any namespaces. So what we started with was, if everything is default, you get to have, namespace of the claim dash name of the claim dash and like, 5 random string, which is actually similar to how, let's say that you have a deployment and it creates a pod, you get to have like, name of the deployment dash and like, 5 random characters. The difference in our case is that managed resources are not, namespaced, so we have to say the namespace, but like it cannot be an actual namespace, so we just put it in the beginning so that like, when we list, let's say our cloud instances, you can see like in which namespaces, like which claims in what namespaces correspond to that. So this is like one decision, and then there is a decision of, managed resource name and the like external resource name, like what you see on the cloud provider console. So in that case, what we want to do, still is reflecting what we see in Kubernetes API. So if it is possible, we want to use name of the managed resource directly. So for example, let's say today, if you create a database claim, let's say in, my app namespace and my database, what you will see in the console is, identifiable with that. You will see and say, hey, this is my, database. And like it's actually exactly same with the Cloud SQL instance managed resource name. Though like, there are also some cases where, users want to override that. So there's also, that possibility. So if you have in the claim a special annotation called like crossplane.io/external-name, you can actually specify, hey, like this will be my managed resource, and its name should be like, my prod database instance. So what we do is, propagating down this external name to manage resource annotation. And then like when we do the create calls, we use that name. So basically you're able to override it. And for the ones that are like non-deterministic, just like the example you gave, the VPC one, what we do is basically we don't have a say in the naming of that. So we do the create call and get the name and put it in the annotation of the managed resource. So basically you will see that in each level, both claim and managed resource, what you see in the annotation is actually the external name. So basically when you create a VPC ID, it's, when you create a VPC, its VPC ID will be on the annotation of the managed resource, and then it will propagate it up to claims annotation. So like this is in general how it works.
Definitely. Yeah, that was a great explanation. I think like one way it actually, so if I've been implementing new resources and stuff, I've had to look back at this documentation a few times because I kept getting confused in my head, essentially how we're doing it, which is actually a pretty straightforward and simple model. But I always think it's nice to kind of like walk through what it looks like. So here in the Crossplane repo, we have some different examples. So here's a Kubernetes cluster claim. So this is to say, I want to provision a Kubernetes cluster on a cloud provider, that has these certain labels and that sort of thing. So you'll see here that there's no annotation set on this. So we're going to follow, as you said earlier, let's see, it's namespace name. And then is it UID of claim and then 5 characters random? Is that it?
No, namespace -name -random 5 characters.
Gotcha. So in this case, then the name of our claim is app Kubernetes, and let's just say the namespace is default. So if we use this Kubernetes cluster claim to say maybe claim a GKE cluster or something like that, so this class here, then the name of the managed resource or the name of the external resource would end up being app Kubernetes default plus 5 random characters. Is that right?
It would be actually, it would start with default, like default dash app Kubernetes dash 5 random characters.
Gotcha. So namespace, then name. Awesome.
Yeah.
And then let's walk through another scenario. So let's say on our Kubernetes cluster claim here, if we set an annotation before creating it, so in our metadata, we had an annotations field and said crossplane.io/external name, and then set a value for that. Let's just say like my cool Kubernetes cluster, then that would be when that claim uses the class here for GCP, then it would create the external resource, my cool cluster or whatever, and then propagate or then also place that annotation on the managed resource, right?
Yeah, so basically the like annotations, like it propagates down, but the name of the CR, the managed resource, is still generated.
Right.
So basically like the managed resource controller looks only at the annotation, and there is like, a mechanism that puts the name of the managed resource to the annotation if it's not empty. So basically it's always, final place is the annotation.
Awesome. Yeah. So that's a great rule of thumb. I love when we have kind of like absolutes like that, when we say the external name will always be representative of the external resource's name on the cloud provider, right? We can always guarantee that. So there's a number of different ways that the external resource name gets created, and that enables us to specify the name if we want, allow it to be generated in a safe way if we want. Or, in static provisioning, let's say this was just a GKE cluster, not a class, and we created it, then it would use the name field here and then set the external name annotation on there for us. And we still have that property of the annotation always represents the external name. So I really love that kind of like absolute model of this, where we're saying we are providing this guarantee to you. So that's actually one of my favorite parts of this entire document here, is our naming strategy, because I think that's really helpful.
Yep.
Let's see. So we've already gone 30 minutes in, and that's probably me dragging us down a little bit on speed. So I might skip over a few of things like field names, because we get into more depth with that. And it's pretty obvious actually how we do that usually. We try and, for the most part, represent the fields as they are in the Cloud Provider API. We talked a little bit earlier about status and spec. So the spec, I want to touch on this a little bit, and we'll skip over status a little bit because it's mostly just, everything that's not in the spec that it says here. But will you specifically talk about late initialization? I think that's probably one of the things that people don't realize, when creating resources. It's basically handling fields that you could set, but you don't have to set and that sort of thing, but you don't want to update them because you kind of defer to the default. So could you talk a little bit about how we do late initialization?
Yeah, sure. Like for spec, we do it only for spec. So what happens is that, let's say you wanted a Kubernetes cluster, and like what you want to specify is just, the required fields like region and node count, let's say. You want a 5 nodes, in US East 1. So as long as, cloud provider allows that, like that many fields, like only these fields are required, you should be able to create it. And then when you create it, the platforms have their own, defaults. Let's say if you don't specify the node type, they would assign you some, default node types, like, 1 CPU and like 2 gigs of RAM and stuff. So in the Crossplane, like in the console, when you do that, you actually see the defaults, and like you can see them, and like you can change them and stuff. We want to enable Crossplane users to do that as well. So what happens is that when you create a resource like with spec, and then after we create, we go ahead and like, get the resource and fill the spec fields. Like if they're not, filled by the user, we fill them with the, the values that we get from the cloud provider, which is actually, a pattern that Kubernetes also follows. In the pod, you see the node, like selected node, like scheduled node. I don't remember if it was like the IP or the node name, but like if you specify it, it will just be, scheduled to that node. If you don't specify it, Kubernetes will schedule it, randomly or with some, other constraint, and then put the value into the spec. So there's like, an idea around like, spec, where controllers should not ever touch spec. So this is not like, and this sounds like an anti-pattern, but it's actually not, because we're not manipulating like what user desires. We're actually filling up the fields that users then, see and change later on. So the important point is we do not override what, user specified in that spec.
Right. Yeah, I think that's a great point. The distinction between, touching the spec essentially with a controller versus overriding the spec. So we'll talk about a little bit and how we specify optional fields and that sort of thing, which are specific to the language that you're using to implement your custom resource and their corresponding controllers. And so it's very important that we never say, if you give us a value to configure this, we will never override that with what the cloud provider says. But if you don't, then we'll set that, because you may want to change it in the future. So a good example of that is I pulled up here a console view of a GKE cluster on GCP. So you'll see that there's a lot of different fields here. There's a lot of things you can configure. The only thing that you have to specify when you create a GKE cluster is a location. So this would be a regional cluster. The one we're looking at here is actually a zonal cluster. So that's all you have to specify. And then they have kind of like sane defaults for you for all the other ones. But after I create this, I might want to update any of these fields. So that needs to be reflected in the spec. Things that can be configured, we need to know what the current value of those are so that we know to update them when we change the value, right? So if I want to, let's say the other day I created a GK cluster, and then I wanted to enable this Cloud Run for Anthos field here, which is in the add-ons config. If I took this configuration here and added the add-ons config block and then changed Cloud Run config to disabled false or something like that, we need to know that at the cloud provider that's set to true. So actually, after creating this, and since this is a class, there'd be a corresponding managed resource that was created. If you kube control describe the resource, you'll see a spec that's fully populated with all of these fields that you see here in the console, even though we didn't set those. But if we change it, so let's say, let's imagine this is just a GK cluster, a managed resource. Our specification still looks like this. So if I had already created it and then just updated the add-ons config field, then it would only change that field in that fully populated spec that we got back that was late initialized from the cloud provider. And then it would go to the cloud provider and say, hey, you're out of line with what my declarative specification says. So I'm going to update you accordingly. So yeah, I think that's another, vital thing to be able to do, or else you can only configure at the beginning, or you're not knowledgeable of the current status of your cluster. You'd only be able to see those things in the console or through separate API calls. So we want, full management from the Crossplane control plane.
Yeah, exactly. And it's also, I think, in terms of documentation, like is a good point. Basically, like when you create the Cloud SQL instance or Kubernetes cluster, you may not know like what name actually corresponds to what, property that you want. Like you can always go to documentation of Crossplane or, GKE, but it's just like, right in front of you, and then you can see and you can go ahead and change the value.
Definitely. Totally agree there. So I think we can generally say that in the spec, if something can be configured at any time in a resources lifecycle, that should go in the spec. And if it doesn't fit that, then it should go in the status. And there's a couple of kind of exceptions where there's a status and a spec. So this is primarily, related to those things where we manage something separately from the resource. So there's kind of like another resource that's reflected in a parent resource, but we manage that separately in Crossplane. So since we are kind of running a little low on time, I'm going to leave any viewers to go check out this document and read that yourselves. But let's see. These are kind of in the weeds here in terms of embedded structs and that sort of thing. But essentially, sometimes, as we talked about earlier, in the SDK, so for instance, right here, this would be a representation from the SDK that's an embedded field in the parent. You'll see that some of these are configurable at some point for the resource, and some are just things we read back, because most REST APIs are not designed in a way where there's a status and a spec, right? They're just kind of like an object that you send, and it knows how to do whatever it wants with those. And so sometimes we run into cases where there is a struct, and this is specifically, for Go-based implementations, that has fields that are part of the status and some that are part of the spec. And basically all we do there is to separate that embedded resource into two separate ones. So you'll see we'll instead create embedded struct spec and an embedded struct status. So that part's pretty straightforward and probably makes sense to you if you were thinking about that. But the other thing I want to talk about, and this will probably lead us into talking about some of that shared logic that we have, and that would be the owner-based struct tree. So you may have seen, like when we were looking at this example class here, that we have the spec template, or in the managed resource, it would be the spec. And then we have this for provider field, which, you'll see something common that you'd think of would be on a resource you configure. And then there's these other fields that are outside of that for provider stanza. So could you talk a little bit about the for provider and at provider directives, and then maybe move on to talking a little bit about why we have those and what some of those other fields are that aren't included in that?
Yeah, sure. So basically, we have two kinds of configuration when we look at a managed resource. One is, crossplane and like Kubernetes specific, such as reclaim policy. Like, what it means is basically, should I delete the resource when I am deleted or not, and other like which secret should I write, connection details of that resource and stuff. So these are like, common to all managed resources. But like there are also, resource specific fields. What we want to do is basically separate them so that we know exactly like what actually goes to the provider as a specification. So basically this for provider struct, like whatever you see under for provider, it's what we send to the provider. Basically spec.for provider means specification for provider. And like spec in general, which has, connection secret graph and stuff is, general specification. And also like we have the corresponding at provider under status. It's basically like, status.at provider, which is self-describing. You see in the status, you have, let's say, see in the spec.for provider, we gave the name and routing config. And then status at provider gives you, IPv4 range, creation timestamp, gateway and stuff. So basically, the distinction allows us, first, like it's an edge case, but like we won't have any name conflicts. Like, if, so basically like provider API object is an arbitrary resource. And like, we don't know what fields that we end up, having, and they shouldn't conflict with our, configuration field names, which is not really, something happens frequently. But like the actual feature that we get from this is basically the separation, and like, for users to know exactly what is relevant for, like what is related, what you get from the cloud as a service.
Definitely. That's a great description. I think that as we look into some of our reconcilers and such lately, that we'll see how we can share some of these fields that are outside of the for provider and at provider structs to do common things across them. As you mentioned, they're common across all managed resources. Another thing that's really valuable about the for provider struct specifically is that it allows us to, you'll see that in a class, we have spec template for provider. And then in this document here, we have something like an actual managed resource that's spec dot for provider right here. And what that allows us to do is when we have claims that basically specify a class and then lead to the creation of a managed resource, is we can actually just take that for provider field and say, this is going to look exactly how it does on the class, because it's literally the same struct in the code. So we can just assign that directly. And that makes our translation from a class to a managed resource a lot easier, because we basically just say, we know this is the configuration for the cloud provider, so this needs to be common across. Some of these other things may be class specific or managed resource specific, but we're not going to worry about those for actually configuring the external resource. So that's another kind of side benefit of that. One other thing before we move on to some of that shared logic and reconcilers is I want to talk briefly about the pointer types and maybe the markers a little bit as well, specifically because this is dependent on the language that you're using. But could you specifically talk about how we use pointers in Go and why that's important, and what the difference between maybe just like omitting a field that's not a pointer and omitting a field that is a pointer, how those two things could be different?
Yeah. So basically the aim for that, specification, like aim for that document to have an idea how whether you use, pointer or not, is basically getting a free validation from the Kubernetes API server. As you see, like there's a link that links to Kubernetes design document. So basically, if you specify it as a pointer type, and also, have the omit empty struct tag, you allow the user create the resource without having to specify that specific field. if you don't, if you just make it, valued like non-pointer type and do not, add the omit empty, just like name here in global address parameters. Basically, API server does not allow you to create a resource without that field, having value. Specifically in Go, what the pointer type, I mean, it wouldn't be actually specific to Go, but like in general, how this works is that, when you have a pointer, let's go from, Boolean, you've got like, normally false and true, but like you might actually, let's say you return a value from a function and you ran into an error. So your answer should not have to be either false or true. You actually don't know what the result is, basically, because you failed to, do it. So basically you return a pointer type and then like you say, hey, this is nil, and I don't know what it could be. And same goes for, Cloud API, like managed resource specifications as well. For example, let's say user creates a Cloud SQL instance, and if they do not specify IPv4 enabled, you don't actually want to, make it false or true. Like you don't, as a Crossplane, as an intermediary, you don't want to have an opinion, even though the language is like default value is false for Booleans. So basically what you do is, hey, this is nil. And like, if Google decides that its default is true, which is the case right now, so we just, fill it in. So this pointer type makes, allows you to have, allows you to be able to say that I don't have any opinion about this. Like for strings, let's also, like empty string is actually a value, like instead of, compared to nil.
Right. Yeah, that was a perfect description. For anyone who wants more about that, you can obviously look at the Kubernetes API design here. There's actually a lot of good stuff in here that we've adopted for Crossplane as well. But yeah, that basically, as Muvafiq said, the pointer type is just to be able to specify. Well, I like to think of the pointer as kind of like a wrapper around it that says a wrapper around any kind of other type that says, for instance, a string. The pointer part of that says, I've either provided this or I haven't. And then the actual value of the string is only looked at if it's provided. So it's kind of like a first layer. So you're probably familiar with that already if you write anything in Go, but it's just kind of like it may not be intuitive when creating kind of API designs and that sort of thing. So thanks for walking through that, Muvafiq. Looks like we have about 10 minutes left here, and I definitely wanted to get over into a little bit of our shared reconcilers and that sort of thing, which you alluded to earlier. I always personally find it really helpful to look at an actual implementation and then go back and look at how kind of the behind the scenes magic is working, because it's hard for me to look at the behind the scenes and know exactly how it would be implemented. So I briefly want to take a look here at an implementation, and I've been kind of deferring to using GK cluster a lot. That's just because I personally have been looking at that a lot lately. Any of these different resources that are V1 beta 1 will have similar patterns here. But one of the things that's really nice about Crossplane is that we have a separate library that's kind of similar to controller runtime from Kubernetes, which basically allows you to build controllers. But we've kind of brought together all of the common logic and made it a little simpler to implement. And we've done that by basically creating 5 different kind of operations. So the first one you'll see, and this would be in all controllers for managed resources, you'll see connect. And then you'll see kind of like the 4 actual actions that are taken. So connect is basically just saying, this is how I talk to the API, the specific API that I want. So for instance, we're talking to the container service API for GCP here for a GK cluster. And then observe, create, update, and delete are the other methods that we're going to call. So as you'll see here, you don't really see a reconciliation loop. Observe is probably the closest thing you'd notice to that. That's because we've taken a reconciliation loop and basically said, we'll take care of the actual loop and making sure we check all the right things. You just need to tell us how to do these 5 steps. So they're pretty self-explanatory, as you would imagine. And instead of saying, in a reconciliation loop, saying, if something's out of whack, then we need to update it or something like that, you just return from your observation, hey, Crossplane, update this for me. So you'll see something like, here's, we're checking if the current spec of the object is matching what we've basically specified as our declarative configuration. And if not, then we want to update that. So this is the late initialized specification. And then here we're checking if the external resource is actually up to date. And if it's not, this is basically just a helper function that we have that's comparing the different fields. Then we just return from our observation method, hey, external or resource up to date, which basically tells the shared reconciler that, hey, next reconciliation, I need to call the update function, which in there we just tell it how to update the resource. So that's kind of like the high level overview. If you look at something like Cube Builder, so let me hop over here. And a lot of this is built on some of the patterns here. So definitely check out Cube Builder and controller runtime. I think that there is some examples in here somewhere. Actually, let me go back to the book here. So this is a multi-version tutorial. I think that, yeah, so there's a controller in here. So this is basically just a cron job controller. So what you'll see here is a similar implementation, but you'll see a really long reconciliation loop right here. So they're basically calling this reconciliation, passing that to the controller manager that says, on this interval or on these certain events, call this reconciliation loop. So they have all of their logic in here. And you can see that can get like a little bit unwieldy over time, and it's not as simple, especially if you're not familiar with writing controllers a lot. So instead of this long reconciliation loop, which you can see even for a simple resource that can get quite long, obviously they have some very expansive comments in here because it's used for a tutorial. But there is a lot that's happening even for a simple resource. And when you compare that to something like this, it's a little bit more logically easy to understand. It also makes, I know when I implement new resources, I'll copy over boilerplate from another one, even if they're very different resources, they're still going to follow similar patterns. So this is generally what it looks like. And what you'll see in the setup with manager is this new manage reconciler function, which is coming from our Crossplane runtime library. So just like there's a controller runtime, our abstraction on top of that is called Crossplane runtime. And I have an earlier episode where I actually use this to create a Slack controller that sends messages and that sort of thing. So if you want to look at a simple implementation of how that can be used, that may be a good point to look at it. So Muvafik, you talked a little bit about some of these different controllers we have and how we started out with basically just the claim one in common. And if you look in here now, we'll see things like claim binding reconciler, claim defaulting, claim scheduling. There's even secret reconciler and then manage reconciler, which is what we were talking about. Could you briefly just kind of like go over like at a very high level what each of these controllers does and how maybe having some of those common fields that are outside those four provider structs are helpful for doing this?
Yeah, sure. So basically, they all mostly share like, same Go, I would say structure, not like exact struct. But like, when you go to, any of the like either manage reconciler or, claim binary reconciler, you will see that we have a reconcile loop. And that is like pretty much what a reconcile loop would look like for each of the managed resources.
Mm-hmm.
It's not like, very simple, but it's actually in one place and the developers wouldn't need to worry about that. So like, we say, hey, implement those 5 functions and we will take care of the rest. And then like, this allows us, to put some, custom logic for like, let's say finalizer handling, connection detail publishing, or some, reference resolving between the resources, or, initializer as like, for naming conventions and stuff. So basically like we do it at one place, and like if others like all the other managed resources that implement this, get actually, you know, when they pump the version, they get them for free. So this is like, you know, managed reconciler for others. So managed reconciler is between managed resource and the cloud API. And like, you know, the glue code between them is written by the developer.
Mm-hmm.
And for, you know, claim binding reconciler, what it does is basically managing the relation between the claim and its managed resource. And, you know, defaulting is like, you know, choosing the default resource class if it's, you know, if it cannot find any matches for the labels and such. But like specifically in the like related to API patterns design, this managed reconciler actually, you know, allows you to, you know, so it's basically a step towards consistency,
Mm-hmm.
and it just makes easier to implement those, you know, patterns. And also, you know, this is like when you look at the structure, like interfaces, like actually like most notable implementation detail here is the interfaces and like how we plug in and out some, you know, objects. And this is like, you know, Nick's initial implementation in the claim binding reconciler, which is our first generic reconciler. So basically the other ones, including the managed reconciler, look kind of similar to that one, and but like, you know, slightly different for, you know, its own use case, you know, for managed resources. You can see here the interfaces that we have. Like managed interface would have, you know, all managed resources would have class reference, claim reference, you know, secret, reclaimer and stuff. One exceptional, like you could see, is the connection secret writer too. So
Mm-hmm.
basically, if you create a network, you don't actually need a connection secret. So basically, you know, thanks to the pluggable structure, if you don't like, you know, when you develop the networking resource, if you just give, you know, empty connection publisher, you just don't write anything to any secret, and like you would just still use it. So basically, there are like, you know, some comments and like defaults, but you are always able to, you know, override them.
Right. That is a great point about the connection secret. I wanted to point out kind of quickly where that's happening. So in this external observation here, we're returning basically our connection secret for this GKE cluster here. And we're basically saying, hey, Crossplane, here's the connection secret. Go put it where it needs to go. So in the case of a Kubernetes cluster or any resource, if it's claimed, then this cluster scoped resource has a secret, but then we want to copy that to the namespace claim namespace. And so Crossplane will just take care of that. If we say, hey, here's our secret, it'll say, okay, well, do you have a reference to a claim? If so, then I need to also put a secret there with that information there. So that's a really good example. Another one that you pointed out kind of at the beginning, let me jump back to that. And I like this one especially. And shout out to Javad. He did a lot of work on this part of our controllers and APIs. Is you mentioned references. So you'll see this comment here, which kind of describes a little bit what we do. So jumping back over to stat GCP, you don't see anything about references here at all, really. There's no thing that says, you know, make sure all other resources that I reference are ready or anything like that. We're just saying, you know, what to do when these 5 specific actions need to be taken. But if you look at the API,
maybe you can talk about like what reference is actually.
Yeah, that's definitely a good idea. So a reference in Crossplane is essentially a lot of times there's configuration that you can specify for a resource. So we're about to look at GKE, for instance. You can specify a network and subnetwork for that GKE cluster to be provisioned in. But we also have network and subnetwork resources represented in Crossplane. And what we want to be able to do essentially is say, you know, use this network that I provisioned via Crossplane. So we reference another object, another Kubernetes object, which is that network resource. So if we look down at network ref here, you'll see there's a network field. So this is from GCP. And then you'll see this kind of attribute reference or annotation that we have on this field. And what this is saying is instead of providing a network, I can actually just provide a reference to an object, and that object will tell me how to populate this network field. So like I said, this is not required here. But if you did want to use a network, you could just reference a Kubernetes object, which is that network resource, and it will wait until that network reports that it's available to be used. And so we don't talk about that at all in our GK controller here, because essentially what happens in our managed reconciler is that before we even observe our resource, we're checking here that all references are resolved. So we have, once again, a common interface for references that say, I can call these methods to essentially make sure that they're resolved and ready. So for instance, if we provisioned a network from Crossplane, it would report a condition of status ready. And that would allow us to continue provisioning our GK cluster, because we know that that network is ready for a GK cluster to reference it. But we don't have to do any of that implementation in our actual GK controller. So that's just a great example of being able to put something in our API and then just letting Crossplane kind of handle that for us. Let's see if there's anything else. Another thing, just to quickly reference those fields that we said are common across. We talked about our interfaces a little bit. So these are methods defined on our different API types that are common. We also have these actual fields. So you'll see something like, I think manage resource, resource spec here. So some of those that we saw earlier, like provider reference, reclaim policy, those are here. And so what this allows you to do is every time we create a new managed resource object, we don't actually put all these fields in there directly. Instead, we can do something like, if we look at an API here for, let's say, Cloud SQL instance. If we look here at the let's see the spec here. Yeah, so here you'll see we have the spec and the status. If we look in the Cloud SQL instance spec, we'll have that for provider field, which is things that we define here. So we have a Cloud SQL parameters struct up here. And then we also have runtime v1 alpha 1 resource spec. And we're just putting that in line in our spec. And so if you look at runtime v1 alpha 1, it's essentially referencing that package that I was just at. So it's just embedding this in there, which allows us to do that without having to redefine those every time. So we both have the actual fields as well as the interfaces to interact with them. And then we can have that strong guarantee across all of our managed resources and claims and that sort of thing, that they satisfy that, because when we implement the controllers, these methods that we pass it into from Crossplane runtime, so jumping back over here quickly, they will only take something that fits that managed resource interface. So if we tried to pass something like let's see where we passed a new managed reconciler. So if we did for resource.manage kind and passed in GKE cluster group version kind, and that did not have the necessary fields or the interface methods, then this isn't even going to compile for us, right? We're going to have an error there, and we're not going to be able to do anything. And then the last piece of this, which I'm kind of speeding through it because we're running low on time, and I have one more question that I definitely want to ask Mubafik before we get out of here, is you'll see we also generate those methods for you. So you'll see generated deep copy. That's something from Kubernetes controller runtime, but then we also generate these class and managed methods. So we were looking at those interfaces earlier. All of our managed resources need to be able to get class reference, get conditions, binding phase, etc. So you can basically just add our package, which is Crossplane tools, that generates these methods for you. So if you have the necessary fields, then those will automatically be generated, and you once again don't have to worry about implementing those yourself. Great. So like I said, we're running low on time. This is a ton of information, a lot of really valuable stuff. I hope that some other people who work on extending Kubernetes were able to tune into this episode. Last thing I wanted to ask you, Muvafit, and I really appreciate you coming on today. Obviously, you have a lot of great insight, so it's very nice just to say, hey, Muvafit, how does this thing work? Because you've designed a lot of it yourself. So it's incredibly valuable to have you as a resource on here. But I just like to, ask anyone who comes on, especially people that work with Crossplane, what's something about the project that either you're working on right now or you're just interested in or thinking about for the future is on the roadmap that you're excited about for the project and that you're looking forward to adding that functionality?
Yeah. So, Crossplane has like, two parts. One is services, which is you and me and Nick are working, and like there's a stacks. So on services side, I'm most excited about the custom claim definitions that Nick has been, doing a one pager, and like, there are some discussions. It's a big topic, but I think it is a great way to, allow infrastructure operators to define their own claims, like, that binds to, more than one resources, like managed resource and resource classes. This would enable like, anyone to just write a YAML that would describe like how you can get high available 3-node cloud SQL instance, like, in a strong type manner. Like you can still do that today, in a folder or like, in some ways, but like it's just gets, easier, like pretty much similar what Kubernetes has the CRDs, but we would have like, an extension to our model, like, custom claims, and that would open up really like different and inspiring scenarios to have. And also on the like stack side, I think like multi-cloud stacks are the things like most exciting for me. And also, like we don't have a great example of that yet, but like, having a stack as a package and like, deploying it multi-zone, multi-cloud, is really, something I'm looking to have in Crossplane. Like, and what are you excited about most?
Well, you touched on a lot of things that I think are really awesome things. One of the things that we've talked about a lot recently, we've actually have a design merge for it. So once again, our good design process is being able to schedule applications to existing and on-prem clusters. So basically introducing a new type that changes how we schedule our Kubernetes applications, which would allow us to target things like if you have your own data center, as long as you can, connect to that Kubernetes cluster with a raw kube config, then you can schedule resources there. So I'm really excited about adding that functionality because that's something that we've heard from the community a lot, that a lot of people want, because there is a lot of people that even if they're not multi-cloud provider, they are kind of like hybrid cloud in that they have some resources on a cloud provider and then some on-prem, especially if they're doing some sort of migration or have special workloads that need to run on specialized infrastructure. And then the other thing, which I think I brought up on a TBS episode before, is integration testing. So we have like lots of unit tests, thousands and thousands of lines of unit tests. But I really am excited about adding the ability to actually test live against the different cloud providers and running those on an actual scheduled basis. So we have more end-to-end data about things working, because in the past we've run into situations where there's some behavior that is only experienced when things are running on the cloud provider for an extended period of time. And if we're on the cloud provider or if we're running resources for a long time or running them more regularly with potentially randomized configuration, then it allows us to more clearly get a picture of how our resources are performing, how strong our APIs are, that sort of thing. And have stronger guarantees around that. So definitely excited about getting some of that automated testing in, because it can definitely become tedious when adding new types of provisioning a bunch of resources manually from the command line and that sort of thing. So that'll make that process a lot more repeatable.
Yep, definitely.
So yeah, I think that pretty much wraps us up today. I'll say for me, this has been my favorite episode so far. I think it's the most useful to the community. Even people outside of the Crossplane ecosystem, just working with Kubernetes in general. So I'm definitely gonna, try and get a lot of people to take a look at this recording because I think it could be useful, especially if someone's new. to Kubernetes. So thanks for joining us today, Muvafiq. Your insight was awesome, and I'm sure a lot of people are going to gain from it. So thank you from all the listeners as well.
Yeah, thank you for having me, Daniel. It's always a pleasure to work with you. And this was my first experience with the podcast, so I hope people were happy.
Oh yeah, you are awesome. I'm sure we'll get some great feedback. So anyway, I think we have stand up coming up. So for everyone else, have a good Thursday. And if you're taking off some vacation for holidays, get some good rest. So thanks for joining us today, everyone.